So I've already built this. This is where we're going to preview everything together. So this is just merging in all the outputs upstream from here. So starting from the dissolving martini glass. And one thing you'll notice here also is I'm time shifting it by 2 frames. And the reason is because otherwise there can be a little bit of a border between where it's connecting with all the simulations, especially the flip sim. Coloring that because we want to have everything color coded. And next thing we're merging in is the flip sim, I believe. Yes. Same thing, coloring it and also grouping it. And in the groups, I'm putting a prefix. I'm prefixing it with mesh for anything that's a mesh, and then PNT for points because we want to split that out later on when we're combining everything together. This right here is going to be our color coded preview. We want a way to quickly see everything in context as we're building it. And that's what this preview is right here. And it's not super fast, but since we've already cached everything, it plays back pretty quickly. So what else on this? Yeah, everything's merging together. And at this stage also is probably where I would start building out the tabs with our main parameters. So what I would do at this stage is edit parameter interface for our global control. And then you can start adding in folders, which are tabs, for each of them, the main simulation elements. So this one we call flip sim. And then call this one, where's the next thing we have? Flip trails. Well, actually Pyro. And another one we'll call main bubbles or bubbles main. I won't do all of them. This is just for illustration purposes. And at this stage, you kind of want to gather together the parameters that you're going to be working with the most. So that's going to be kind of subjective, really, but you can see where this is going in terms of things like you'd probably want to change the voxel size. You'd probably want to change maybe the sourcing velocity, things that you would want to update as you're iterating through this process. Because one thing you don't want to be doing is kind of traversing this whole network, trying to find parameters, and you can gather them together very simply in one area. So say, edit parameter interface and say float. And that would be maybe, it's similar to making an HDA, but we're not actually, you're just building an interface. It's, you're not packaging anything together. It's just linking parameters. Call this voxel size for the name and then the label. And we're just going to add two just for so then you can take those And I don't know what the sourcing we were using. Source scale, could probably call it that. -20. Copy those parameters and paste. And it takes, it'll take a few minutes for you to set up a panel like this. And then it'll save you so much time later on. And then at a glance, you see all of your main parameters. So copy parameter and then go back to sourcing. Paste relative reference. This is also very handy when you're doing things like ramps and the things you'll adjust a lot, like particle scale, their lifespan, things like that, that you'll have to dial in through a lot of iterations. So does that all make sense?
Yep.
Yeah. Okay. Yeah. So this is where all your previewing would happen. And this is pre-meshing. Now, Deborah, let me know how we're doing on timing, because we could either talk about some other details or we could get into meshing.
We're getting close to the 2 hour mark, but I think you can keep going, don't worry. And
Well,
if people have to go, they'll go.
well,
What do
the
you
reason I'm
think?
asking is because
Yeah.
the meshing might actually be a good subject for the next
Okay.
class.
Let's do
Yeah.
meshing for session 3.
Yeah.
Yeah.
Um, so do you want to take some questions?
Yeah. So if you don't mind, can we go back to the pop force area?
Sure.
We had a curiosity that we want to settle.
Okay. Yeah, absolutely. Okay. Okay.
Sweet. Okay,
Pop
great.
force.
Yeah. So, we kind of established like when you want to do a component. So if you have a vector, like swirl scale or offset or
Yeah.
force,
Yeah.
how do you get the component? Is it with the dot X or was it just straight X?
Uh,
Because it's different since this is referencing parameters and not attributes.
right. One thing I have noticed is, even though uh, if you mouse over and you see it says force X, force
Yeah.
Y, force Z,
Yeah.
that will not work.
So if
Like,
you just type, yeah,
no,
go ahead.
that will not work. Um,
So is it force dot X?
that's a good question. I don't know. I've actually I think originally I did try to set it up that way because I thought, well, this must be force X, force Y, force Z, because those are the
Uh-huh.
parameters, and it didn't work. And if you look at any of the reference, examples,
Yeah.
none of them are using components like that.
Okay.
So I'm sure there's a way around that if you just wanted to reference one component. I actually haven't run into a situation where you would want to do that,
Like let's say
where you
you
would
just
need to.
wanted, yeah, right, because you have the access to the vector. But I think we just wanted to solve like a curiosity. Like, for
Sure.
example, if you did force X, would it just give you an error? Like if you put it in the, yeah.
I think it just didn't do anything. Let's try it, because I do recall trying that. Now it's actually not too big a deal, because since force is just operating on this entire vector,
Yeah, yeah.
you could just add another pop force and do the same thing, and then just change put the value in X that you want.
Mm-hmm.
You know, that would be the way around that. But my sense is that actually is not going to do anything.
Okay.
Um, we could come back to that because I think it might be a little slow to try it out.
Oh,
But
I see. So we'll settle this on Discord, everybody.
yeah, yeah, totally. Yeah,
But great questions there.
yeah.
And then I had a question, if you don't mind bringing up your two M plays that showed the final render and the colored mesh
Yes.
yeah, those two.
Yeah.
So the part that's the red mesh,
Yes.
I see. Okay, that just gets rendered as like Yeah, that really adds to it. That's really cool. It's like almost like it's melting into bubbles.
That's the idea. I think the idea, and there are more sophisticated ways to go about this, to go um, to transition from the flip simulation into particles. This worked actually really well, I
I
think,
think
in
it looks
this
great. Yeah.
particular situation,
Mm-hmm.
because there's two things that are happening, like the smaller foamy bubbles and the larger, larger bubbly bubbles, so to speak.
Mm-hmm.
Yeah, what's red in the color coded preview there is the flip simulation.
And then the super tiny ones really sell it.
They do. Yeah, that
Mm-hmm.
that kind of foamy. And what's in the next chapter we'll get into meshing, which is very critical to how this all um, works out. And as you recall, in our flow chart, we're doing a thing where we separate out points based on their p scale, and points above a certain p scale will mesh with everything else, and points below that threshold will render as point primitives, which is
Awesome.
a very critical part of this whole process.
We have
Um,
another question from Igor. I was curious how to cook the entire top cache chain.
well, first of all, be sure to set a path for your particular in your aliases and variables. Everything should be referencing this variable called cache. So be sure that that's set to a local drive. And then just sometimes if you're doing it for the first time, you're running these caches for the first time, you may want to start from the very beginning and just go generate node. Theoretically, all you really need to do is go to this bottom top node here, this merge, and just go cook node. Everything above that should then start cooking. But
Cool.
sometimes if you're troubleshooting something that may not be working, you may want to start from the beginning to see what's happening. And in that case,
Um,
you can just go cook node, see its output. Okay. Then go to the next one, cook this node one by one.
nice. Another question from Christopher. How do you not ensure the dollar sign job is set also?
$ job. Um, not sure.
Are
I use
uh-huh.
both.
Yeah.
Yeah, I use both. I actually use when I'm working locally. Now, this is a good thing to keep in mind. If you're rendering things on a cloud or on a farm, if you're working at a company or something like this, then there's going to be very specific path variable requirements. This is really only applicable to your local drive if you're running things local. And as you can see, there's a couple things that I set. I'll set a job path that's the overall file path to everything. And that's actually different than my cache directory. And this is a personal preference. You
Mm-hmm.
can totally set up your ROP paths to be to job. And
Mm-hmm.
the reason I do it this way is because I like to have larger work files on a different drive for the sake of daily backups, to keep that lean.
Mm-hmm.
I also have a path called lib that goes to my assets, so I can easily get textures and geometry outside of my current project.
Mm-hmm.
So does that make sense? I'm not sure. That was a rambling.
No, that's no, this is your job is referenced in the caches and is being used.
Well, it can be, but if you look in here, actually, this is a good segue into something that's kind of fun. Um, if we go, let's go to the master. Actually, if we go to the ROP geometry outputs that I'm using for all of my caches, they're referencing cache, and I have them set to do that. I think by default, if you haven't done anything with a ROP geometry output, ROP geometry node, it's going to be set to either hip or job. But what you can do is you can set a file token path that makes sense to you and go up here and go to save as permanent defaults.
Mm-hmm.
So then every time you put one down, it'll have the path that you like.
Did we answer your question, Christopher?
Yeah.
So I think you're seeing something that we might not be. I think we're good.
Okay.
Um,
All right.
yeah.
Yeah. And then very briefly, I wanted to, since this wasn't in the last work file, and actually another reason I would use this one is because I did make an error and you in your path uh, token and your token string here, definitely have your frame padding at the end. I believe I had a version number. That's the last token, and you don't want that. What this is, while we're here, I put down a file cache. I called it the deconstructed method of doing file caching. And the reason is because if you put down a file cache and dive inside, you'll see it's doing the same thing. You have a ROP geometry and a file load that's reading the output from that. And then a switch, and that switch is just this load from disk toggle right here. So we're doing the same thing in a deconstructed way, only we're doing our load from disk and we're gathering them all in one place. And that also brings me to this version slider, which is handy. If you're doing multiple versions, you can, even though at the moment this is not doing anything fancy, you actually have to type in the version that you're, well, you don't have to with the slider. You can reference the slider here in the way this is. You know what? I will copy this into a Wrangle window so it's more visible. Let's see, Control E, right? Yeah. So you will have to link these manually. You can see I have the token path here and the V0, and then backticks right here. This string right here is referencing it's referencing as I scroll all the way up. This point cache version. So if you can see the name is PNTS cache version. And then if I change that, if I have a cache that's version 1, then it'll load it automatically, which I think I do actually. So or not. Well, there's no points yet. Here we go. Yeah. So yeah, I do have two versions. I believe I made two versions with different size points. This is when versions come in handy if you want to compare caches. So yeah, that's version 2. And if I switch this to version 1 or this one, here we go. Yeah. So you can easily flip between different versions and compare them. Very handy for doing things like if you're doing, well, wedging, you probably want to do that with tops anyways, but you could set up kind of manual wedging like this as well. Does that make sense?
Yeah.
Okay. I believe I'm looking at my notes here. Control panel. Yeah, I think this meshing thing might be better.
Yeah.
Save for the next. If we want to take any more questions, by all
Any
means.
other questions, anybody? I think we might be good. Although Philip, I think, discovered an answer for the force.
Oh, perfect. Okay.
Do you want me to say it?
Yeah, say it.
Yeah, absolutely. Yeah.
Okay,
Don't
cool.
leave us hanging.
No, I just made a very basic Vellum setup with just 5 different spheres, and I disabled gravity, just applied a pop force node so you guys knew what I was doing.
Uh-huh.
And I set 2 directions on the force parameters, so it's 0.5 in positive y and 0.5 in positive z. So then when you make a distinction, it should work, right? Because it's 2 directions.
Mm-hmm.
If it works, it will offset. I did a connectivity as well, so I have a class attribute.
Mm-hmm.
And I typed the expression force dot z times equals that class. And now they are offset on z and going up as well.
Oh,
And did you try without the dot and did it not
Good
work?
point. I will do that right now. Let me see. I didn't. No, it gives an error right away. No. So it has to be with the point, with the dot.
Okay, it does not work without the dot.
No, it does not. It gives you a lot of
Aha!
red some things, and it's not working. It's an error.
It's
Yeah.
with the dot.
Yes. So
Oh, it
you
is.
can do
So
both.
dot does work. Okay, well that's very good to know.
Mystery solved. Good job, Philip.
Okay.
Thank you. Nice. I'm
Yeah.
happy. Cool.
Um,
We have another question here from Igor. Would the workflow need a lot of tweaking if we were to use animated source geo?
yeah. Now, you would need to set um, a REST attribute, and there are a couple other considerations, but the main idea is that you would want to run the growth solve in REST space, and then once that's deformed into the animation, you'll want to also add the velocity of any deformation into that as well. So you've got the velocity of the growth solve and added velocity for whatever motion's happening. Let's say crag, for instance. We can revisit that maybe in as a project on Discord.
That would be great, Andrew, because I think
Yeah.
that was we got that question last
Yeah.
session as well. So
Absolutely.
like as a little addendum, I'll talk to you about that offline and we can add that in.
Absolutely, yeah.
Sweet.
I'm looking over. If I look distracted, because I'm looking over all the fun stuff in the chat. I hope this all made sense. I'm not going to say there weren't errors. I'm sure in a multitude of words, and
No,
there's going to be maybe an error.
it's all
mentioned here and
good.
there.
It's all amazing information and
yeah.
knowledge that I just want everybody to take what you learn and make something cool.
Go for it.
Yeah, and
Yeah.
submit in the homework, put it on social media. I just also shout out to Zahra and Philip. We saw your social media posts and thank you, thank you, thank you. Huge. It means so much to us. And everyone else, thank you so much for coming. And it's so fun to do these. And yeah, this is awesome.
Yeah.
So
thanks everyone. Thanks for it's been a blast.
great. So we'll see you guys next week. Yeah, for session 3.
All right.
Okay. Bye.
Bye.